So for this one, solving a compound inequality, linear inequality, and then graph the solution. When you're going to go to solve, I want to show you a way that you don't have to memorize every different case. But I think that it's good for you to know, first of all, what's the difference between the word or and the word and. So or, if the number makes at least one of the little mini inequalities true, then it's a solution to the entire thing. But when it has the word and, then the number has to make both inequalities true. As far as this goes, really process, sometimes you're going to see the two separate inequalities written with the word or already in between and the word and already in between, and sometimes they're stuck together. In this particular one here, an easy way to help you remember which is which is if you sound it out, just being dramatic in your speech here. This symbol right here does not make the letter L, and so it's greater. But if we emphasize the way we say that, the way we hear that, greater. See how that one sounds a lot more like an or than an and? Greater. So whenever your symbols are greater than or equal to, it's an or problem. In this one right here, this one makes an L, so that's your less than. And if you exaggerate the way you say that, less than, so the one that sounds like and, there's an and in between. And the meaning one more time is you're going to have a number in the solution set if it works for at least one. And when it comes to this one, it's going to have to work in both. So first thing I'm going to do is separate these. So basically, process, you just cover this one up and you write this one. And then you cover this up and you write this one, and that's your two separate inequalities. Whoops. Bad. So cover this up and cover this up. And because the original symbols are greater than, the word in between that you write is an or. Now I just have two inequalities that I want to solve. So I keep going. I'm going to get x by itself. I'm going to add 1 to both sides. Negative 5 plus 1 is negative 4. Greater than or equal to comes down. Add 1, got rid of minus 1, so I have 2x. Lastly, to get rid of multiply by 2, I'm going to divide by 2. Remember, this symbol only flips over if you multiply or divide by a negative number, and we're dividing by a positive 2, so it's not going to flip over. And negative 4 divided by 2 is negative 2. It's fine if you leave it like this. This says negative 2 is greater than or equal to x. I think it's easier to read when the variable is on the other side. So if you want to change the order here and put the x on the left and the negative 2 on the right to make it easier to read. Notice the alligator right now is eating the negative 2. So when I flip this around, it still should be eating the negative 2. So if you flip this around, you've got to flip your inequality. So I put my x on the left, my negative 2 on the right, and when I flipped this, the inequality flipped over, it's still eating the negative 2. Okay, I want to do the same thing here, solve this inequality. So I'm going to add 1 to both sides. And I have 2x then. Greater than or equal to comes down, and 9 and 1 makes 10. get rid of multiply by 2, so I'm going to divide both sides by 2. And then x is by itself. I'm dividing by a positive, so this does not flip over. And 10 divided by 2 is 5. So I have x is greater than or equal to 5. My final answer, not the graphical answer, but my final answer is x is less than or equal to -2, or my x's are bigger than or equal to 5. So that's my final answer. Now it wants me to graph it. I'm going to go to my number line and I'm going to put a solid dot at -2 because this is underlined. I'm going to put a solid dot on 5 because this is underlined. Solid dot on -2. Solid dot on 5. Numbers that are smaller than or equal to -2. Numbers that are smaller are on the left. Numbers that are greater than or equal to 5 are on the right. And so here's my final graph. Just a visual cue for you again is if it's an OR problem, it's a little bit silly here, okay, but oars are like paddles. So if you're paddling a boat, you have your oars. So if you have an OR problem, chances are the arrows are going to go away. That is a shortcut, so it doesn't always work for special cases, but you guys are not going to find any special cases today, so it should at least give you a good feeling that, okay, I think I have this one right. No one asked me this question. When I'm determining ORs, nobody said, well, what if those are facing different directions? Right? What if these two that I have highlighted are different directions? That will never happen. It'll never happen. When they're written as one statement. So if you had this one right here, you see how I can put 2x minus 1 in the middle? Because it's what's in common. The bigger number between -5 and 9 should go on the right. So see how 9's on the right, -5 is on the left. And then between the 9 and the 2x minus 1, it's eating the 2x minus 1. See how the alligator's eating that one? So between the 2x minus 1 and the 9, it's eating the 2x minus 1. And right here between the -5 and the 2x minus 1, it's eating the -5. If it's written separately, you might see them facing separate directions. But when you write it as one piece, they will always be facing the same directions. If they're written separately, they're going to have to tell you if it was an and or an or. And then you wouldn't have to come up with that word by yourself. Okay, so here is the other one. I have -10 is less than -3x plus 2 less than 8. One more time, because those are both less thans, I'm going to have an and in the middle. And then when I write them separately, I'm covering up the less than 8 and writing down the left side. And then I'm covering up the -10 less than, and I'm writing -3x plus 2 is less than 8. So I have my two separate statements. I need to solve each one of these, but in the end, the x's are going to make both of these true if it's a part of the final solution. All right, so let's subtract 2 from both sides. And then I'll have -12 is less than -3x. To get rid of multiply by -3, I'm going to need to divide by -3. And when you divide by a negative, the inequality flips over. So -12 divided by -3 is +4. This is going to flip over, and then I have just x. If you would like to have the x on the other side, I can reverse those, put x here, 4 here. It was eating the 4, so it's still eating the 4. Okay, so it flipped over from here to here because I divided by a negative, and it flipped over from here to here because I just changed the order. Okay, so one more here. I'm going to subtract 2 to start getting this one by itself. So I'll have -3x is less than 6. Divide both sides by -3. Because I'm dividing by a negative, that's going to flip over. And I have x is greater than -2. So now we're going to finish this graph here. I have no underline. So at 4, I'm going to put an open dot. And then if I have numbers that are less than 4, that's heading this direction. This won't be my final graph. For x is greater than -2, I'm going to have an open dot at -2. And numbers that are bigger than -2 are this direction. The word and means it has to work for both. So numbers on the red one work for this one. Numbers on the green one work for this one. So if it's going to work for both, it's on the overlap, which is in between. So my final graph is going to be connecting up the middle. But a shortcut on this one is I see the word and, so ors usually go out and ands usually connect up. Another way to look at it is once you get these main numbers, -2 and 4, just go in and test a number in each section. If you put -3 back in the original, it would not be true. If you put a number in between, like 0, into the original, it would be true. And if you put a number on this side of 4, let's say 5, into the original, it would not be true. When they're written side by side, and means it has to make both true, and or means it has to make at least one of them true. Okay. There's 98. The next one.